Happy Friday, everybody. Would you take out your assignment from yesterday, recorded on your gold sheet, 5.5, Day 1, page 331? I will come back to the gold sheet in a second. Just make sure you have your assignment out because I want you to correct your homework. Make sure that you did everything right. If you need some time, go ahead and pause me. So just a quick recap, we were talking about triangles yesterday, and we talked about how if you could find the largest angle in a triangle, that the side that's opposite, or straight across from it, would be the longest side in your triangle. And then if you could find the smallest angle, the smallest side would be across from that. So it just helps us understand the relationship between sides and angles. If you would take a minute now to get that packet stapled together, hand it in up front. Again, pause me if you need more time. And today we're talking about more relationships, but really it's all about sides today. We want to talk about what types of side lengths can make a triangle and what types of side lengths can't. For example, a 6-foot, 9-foot, and a 12-foot board will make a nice triangle. But if you try to do the same thing with a 6-foot, 2-foot, and a 12-foot board, not going to work, not going to span, not going to make a triangle. So what is it about numbers like these, like the 6 and the 9 with the 12, and the 7 and the 7 with the 12, that works? Think about it. At the same time, you should be thinking, why doesn't a 6 and a 2 and a 5 and a 4 work? If you think you have an idea, will you turn to the person next to you right now and tell them why you think some of them work and some of them don't? What's the criteria? Hopefully you heard some good ideas. I'm going to show you the way that makes sense to me. That this has always worked pretty well for me. I like to think of the biggest side on the triangle. So on all of these it's going to be 12. And I like to think of that as sort of like a river, some sort of water. And I want to make a bridge across that water. And so a 6-foot and a 9-foot board is going to do a nice job of getting across 12 feet of water. Where if you had 12 feet of water and you were trying to walk over it with only a 6 and a 2-foot board, not going to work so well. And the idea is, maybe you just talked about this, that 6 plus 9 is 15. And since that is bigger than 12, it reaches all the way across and it can make a triangle. The ones that don't work, maybe you said something like this, the 6 and the 2 only make 8. And 8's not big enough to get all the way across. So maybe we could say it's not bigger than 12. Or we could say it's less than 12. So that's really what we're going to talk about today, about how 7 plus 7 is 14. 14 works nicely, it's bigger than 12. 5 plus 4 is only 9. 9 is not big enough to go all the way across 12. What we're talking about here is something called the Triangle Inequality. It's a theorem. I think it probably makes sense to you, but it can be proven. It says that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So the two sides have to add together and be more than that third side. To me, you really only have to show this once. They have all three of these inequalities shown. But if you can just find your longest one, that's really going to be enough for me. You want to make sure that the longest one can be surpassed, in a way, by the other two. So here's an example. Here's what you're going to have to do for homework. If you had a 3-foot, a 6-foot, and a 1-foot board, are you going to be able to make a triangle? What I like to do is I like to think about that biggest one. So if I had a 6, am I going to be able to get across the river with a 3 and a 1? And I'm going to go with no. And so you can say no. If it asks you to explain your answer, here's what I'm looking for. I just want you to say that 3 plus 1, which is only 4, is not bigger than 6. I kind of like you to write it like that because we're always thinking bigger. Is it bigger or isn't it? Okay? So that would actually be your answer for a problem like that. How about a 5 foot, 10 foot, and 7 foot board? Is that going to work? I'm thinking this one's yes. Because if we just did a no, she probably made a yes. I feel like I could do this. I'm going to go yes. And my justification is that 5 plus 7 is 12, which is bigger than 10, and that works well. So I want you to spend a couple minutes, and I want you to try these 4 examples. I want you to figure out if it's yes or no. Work together if you want, but I want you to write down your answers. I want you to write down some yes or no answers. Go ahead. If you're still talking and you need more time, go ahead and pause me. If on this first one you said no, that's also what I got. What you should do is take out that big one, try the 2 smaller ones. 13, not going to do it. 13 is not bigger than 15. So the first one's no. The second one, I'm going to go with yes. We're going to try those 2 smaller ones. 22. 22 is going to work. It's going to get across that largest one. They're not always going to be written in order, so you have to think about it. Next, I'm going to see if 15 is possible. I think it is on this one. We can do better than 16 with a 6 and a 10. That would make 16, which is more than enough to get across a 15. Last one's a little strange, isn't it? So you pick out the 14. And what's going to happen when you lay down a 5 foot and a 9 foot board? Well, they're going to actually meet. It's going to be a 5 foot and a 9 foot board that spans a 14 foot. Really, you're just going to have a big old flat bridge. That's not a triangle. So yeah, maybe you could get across the river, but I'm going to say no, it's not a triangle. The math works really well. Is 14 bigger than 14? It is not bigger than 14. And so we would say no on that one. It was a close call, but not quite a triangle. I bet a 5.1 and a 9 would have worked, but not a 5 and a 9. That's similar to these types of problems. If I give you 2 of the sides of the triangle, I want you to figure out how long would you cut that third board. And there's actually lots of different answers. It's not good enough just to give me one good answer. I want to know, like, what are all the possible answers? And so I'd ask you first, which is biggest? 5, 9, or x? Say it out loud. What's biggest? 5, 9, or x? Maybe you said 9. 9 is the biggest number I see right there, but isn't it possible that x might be the biggest? We don't know what it is, so it could be the biggest, and that's kind of where I'm going to go with this. There's kind of 2 scenarios. Either 9 is the biggest, or x is the biggest. So either 9 is I'm going to call it my base, or x is my base. So let's see, if 9 were the biggest number, and I wanted to get across 9 with a 5 and an x, what would have to be true about those two lengths? We're going to just do what we've been doing the whole time. The 5 plus the x would need to be bigger than 9. Let's look at the other possibility. If x is the biggest number, we'd have a 5 here and a 9 here. And so as far as x goes, as long as the 5 plus 9 is bigger than x, this should work, right? So those are the two scenarios. I'm actually going to solve these inequalities, like algebra style. I've got x is bigger than 4. So that means 4 is not going to work. That's going to be sort of the flattened out triangle case. But if we stay bigger than 4, it should be fine. And then on this one, I get 14 is greater than x. Sometimes that's hard for me to think about, but if 14 is bigger than x, then x is smaller than 14. That's how I like to write it. That's just a warning, like, yes, I want my x value to be bigger than 4, but I better not go up to 14, because if it's up to 14, I'm not going to have a triangle anymore. So my final answer would be anything between 4 and 14 would work. A 12 would work. An 8 would work. There's lots of different possibilities. An 8.5 would work. Any length that's between 4 and 14 is going to work. And so that's how you would write that. You say x, or 4 is smaller than x values, and x is smaller than 14. That's how you write anything between 4 and 14. One more time. Now, there is a shortcut for this. I never remember shortcuts, and so I like to reason through it every time. I like to think, okay, what's my big one? Well, could be 10, unless x is huge. If 10's the base, then I'm talking a 3 and an x. If x is the base, then I'm using my 3 and my 10 on top. So again, if I want a 3 and an x to reach across a 10, the 3 plus x better be greater than 10. If my 3 and my 10 are going to reach across x, my 3 and 10 add up to be more than x. Again, when we solve these, subtract 3, we find out that x is bigger than 7, and 13 better be bigger than x. So that leaves me with numbers between 7 and 13. Some of you see the shortcut. Like I said, I forget the shortcut, so I bet you will. You have a lot of things to know in life. This is my job, and I forget it. So it's nice to have this trick under your belt to just think of, okay, which one's longest? There's always going to be two scenarios. It's not okay just to give me one value of x that works. In fact, like 7 wouldn't work, but 7.1 would work. It'd be a pretty flat little triangle, but if I put a 7.1 right here, I could do it. So it's not just like whole numbers 8, 9, 10, 11, 12. There's lots of possibilities. So that is called the Triangle Inequality. It tells you what 3 lengths is able to make a triangle and which ones aren't. Your assignment is 5.5 day 2 on the backboard, page 331. Have that done by Monday. Have a good weekend. Make good choices.